Hello. Hi, Jane.
Hey, I'm Makar.
Hello. So, welcome everyone. Thank you for joining us or continuing to join us for those who have been following us. Yeah, thanks for participating in Attempts 24. Pardon my background noise here, like everyone else, family in the area. So my name is Amilcar Padilla. I'll be your moderator here. I'm the head of Solutions Engineering at Ateme. Today we're going to be presenting Refine Your ATSC NextGEN TV. Our presenter will be Jing Zhou. He's one of our senior sales engineers in North America. And quickly, before we get started, if you have any questions, feel free to submit them on the little Q question button at the bottom of your screen. And we'll do our best to address them either as we go on or at the end of the presentation. And without further ado, why don't you take over, Jing, and give us your wonderful presentation.
Great. Are you seeing my screen okay?
I can see it, yes. I think
okay, great. Hello, everybody. Welcome to Ateme 24. We got some great stuff for you today, and it's clearly about something over the air. Today, we're going to help you refine your ATSC with NextGEN TV. So a brief introduction of the hosts. I believe Amilcar already did some of that. I am the speaker, and my name is Jing, Senior Solution Architect, and I have been with Ateme for a little more than 2 years. Prior to this role, I had spent about 11 years with Discovery, managing various automation playout systems, and later on the global business continuity planning. Our moderator is Amilcar Padilla, who is leading the North America Solution Engineering team. We're going to make it very easy for you to understand everything about NextGEN TV, and of course, most importantly, how to turn it into a very meaningful tool and powerful weapon to work for you. So I've got 8 topics I'd like to share with you today, and here they are. What is Ateme? What is NextGEN TV? Why would I care? How to ATSC 3? What's the catch? How can Ateme help? And why Ateme? And of course, if I haven't bored you by then, hopefully we'll finish with a quick demo. Let's get started. First of all, what is Ateme? Yes, it is pronounced as Ateme. Our first instinct is to call it like Ateme or Ateme, but it is actually Ateme. Ateme was founded in 1991 as a design company and then went public in 2014. So at the very beginning, we provided like software libraries and design references to companies like Thomson, Harmonic, Snell and Wilcox, Tandberg, Ericsson, you name it. And of course, over time, they all became competitors of us. That's why eventually we decided to devote our focus into developing advanced video compression algorithm and has become an expert in this area. In fact, we were so successful that the French government chose us to research and demo the benefits of HEVC through the Forever project. As you can see here, last year has been an extraordinary year for Ateme, where our revenue is increased by another 18%, reaching 66 million euros or 73 million US dollars. We have 300 people in 18 countries, more than 800 clients in 100 countries. With our cutting-edge compression technologies, we have been recognized as the ecosystem leader and holds numerous patents. We're the only profitable video delivery vendor out there, and we continue to grow. We keep recruiting the absolute best people in the field, and we're also actively looking to acquire other companies. Our revenue has been growing month to month, year by year, and over on the right are some of our first tier customers, just for your reference. So here are some more proofs that we're involving every single cutting edge video delivery research and development groups. You might have already seen similar slides during other presentations. So I'm just gonna go through it quickly. We have the Alliance for Open Media, VVC, AV1, NextGEN TV, and many more. So that's a brief overview of Ateme. Now let's find out what is NextGEN TV. NextGEN TV is a new broadcast TV standard, which basically enables the possibility for us to deliver like say full 4K UHD content and at the same time, the interactive smart TV features to local viewers over the air. It basically combines like the interactivity of streaming, of course, the low cost of local broadcast TV at the same time, the high video and audio quality of traditional cable or satellite. Just to make things easy, I would like to think it as a hybrid between broadcast and broadband technology. The term NextGen TV is mainly for marketing purposes. Among the broadcasters, it is typically referred to as ATSC3. So now let's take a deeper look at ATSC3. ATSC3, it's an update to the ATSC1 standard, which officially replaced all the analog TVs back in 2009. But unlike ATSC1, which is purely over the air, or OTA as we typically call it, ATSC3 makes use of both over the air signals and the broadband. So that's why there's a very intriguing slogan that says ATSC3 is when OTA meets OTT. What are the benefits introduced by it? Here we go. The first major benefit is the new codecs, which means much better video and audio experiences, just as we mentioned earlier. On the video side, we have HEVC codecs, SHVC, which stands for Scalable HEVC, we'll explore deeper later, high dynamic range, also known as HDR, high frame rate, HFR, wide color gamut, WCG. So all these allows for a much more colorful, much more smooth, and much higher resolution programming over the air. Audio quality is improved as well using MPEG H3D and Dolby AC4. This allows up to, I believe, 7.1.4 channels to support amazing experiences such as immersive audio. There are actually a lot of great examples on YouTube or any other video sharing website you can find about immersive audio and how much it will change your viewing experiences. The best part is this standard ATSC3 also allows for future extensions, which potentially means that we could even have added benefits such as 8K resolution one day. ATSC3 also brings transmission robustness, which means you will receive more channels in higher quality without needing a larger antenna. Because it's leveraging IP and internet, you will also be able to watch it on your phones, on your tablets, your game consoles, and even in your cars. And it's no longer a one-way street. Everything is interactive with a browser-like behavior. Last but not the least, we have advanced emergency alerts, which is also part of the standard. It includes much more accurate geo-targeting. One particular example is that you will be able to broadcast evacuation routes to a specific area during emergency. So here is a closer look at how much the new video codecs has really changed our lives. It can save on the bandwidth with the same video quality, if not higher. Impact 2 is what we use currently in ATSC1, but it actually came out back in 1993, almost like 30 years ago. H.264, or typically referred to as the MPEG-4, is widely used among cables and satellite, came out around 2003, provides 50% bitrate savings over MPEG-2. HEVC is what's defining ATSC3, which provides another 50% on top of the H.264 or MPEG-4. So that's like an outstanding 75% bitrate savings over the current MPEG-2 codec in ATSC1. And then we also have AV1, came out in 2018, which I like to consider as like the royalty-free competitor to HEVC. I believe YouTube has been running all videos 4080p below with AV1 for almost a year now. Yeah, I think it started like May last year. So there are also MPEG-5 and VVC, and they all provide even more bitrate savings. As mentioned before, ATSC3 standard was designed to leave rooms for future extensions. So maybe one day we'll be able to achieve more as technologies evolve. So now you will probably ask, yeah, this all sounds great, but what is really in it for me? Why would I care? Well, I would say there are more than a dozen reasons for you to want to care, but I'm just going to focus on what I believe is the single most important one. That is the capability to do targeted advertising in the ATSC world now, or a more accurate term for it, dynamic ad insertion. Because we can now offer a tailored, personal, dynamic experience to all the viewers. All the viewers and consumers, they have expressed tremendous amount of interest, want to migrate to ATSC3. And then at the same time, it's also because of the interactive behavior and a much more accurate audience measurements. The broadcasters now have the exact same powerful weapon to do targeted ads, just as YouTube, Netflix, Hulu, Disney Plus, all those extremely successful OTT service providers throughout the recent years. At the same time, the advertisers are also going to be very interested in this type of business model because it means reduced spending and a much higher return of investment, briefed as the ROI on this slide. In the end, everybody becomes happier because of the new benefits they will be receiving in ATSC3. And this is what I believe another important factor why we often say ATSC3 is when OTA meets OTT. So I wish by now you do feel that you will care and even get excited for ATSC3. Let's take a look at how to deploy it. So over here, we have a typical ATSC3 distribution diagram. We have, let me put up the pointer for easier. Yeah, so we have the Ateme Titan that handles the encoding and then dash MMT packaging. We have multiple vendors, takes care of the guide builder that creates a route protocol for service delivery. And then we have the scheduler that allows the physical layer pipe or PLP allocation, which in turn feeds the modulators, and then you'll be able to receive it through your traditional TVs as well as various OTT players. Here over at the top, as you can see, is our capability to do dynamic ad insertion, which, as we talked about, is the absolute most important reason why everybody should get excited about ATSC3. And over here is a closer look into the Ateme Titan encoding piece with a focus on utilizing all the new codec features mentioned earlier, as well as SHVC, the scalable extension in HVC. As promised, we're going to take a closer look, but it's probably not going to be close enough. Just from a 3,000-foot high-level view, SHVC is the scalable extension in HEVC. So it's designed as like high-level syntax-only extension to allow reusing of existing single-layer HEVC codec cores. I believe the name itself is very self-explanatory. It is about making everything scalable. So we already enjoyed the temporal scalability in the first generation of HEVC, and now we'll be able to enjoy more scalability, like in the spatial, the signal-to-noise ratio, often abbreviated as the SNR, in bit depths, and also in the color gamut. And there are a lot of benefits associated with making everything scalable, as I understand. There's going to be less bandwidth consumptions, it's going to be less network congestions, and less storage size to occupy. Of course, you'll be able to receive more programs or high quality programs. Amazing stuff, isn't it? But what's the catch? There's actually no catch. I'm speaking like a sales guy now. No, of course there's a catch, and it is regarding the deployment of ATSC3. With new opportunities, here come the new challenges. While ATSC3 itself is voluntary, FCC does mandate the stations to maintain the same signal in ATSC1 for at least 5 years. And unlike back in 2009, where the stations were given temporary bandwidth for the DTV transitions, this time there is no new bandwidth for us to have. And of course, it would not be possible to broadcast ATSC 1 and 3 on the same transmitter. One way to solve this problem, as suggested, is for multiple stations to conduct some channel sharing so that you could have like all the ATSC 3 programming on one or more refined transmitters while squeezing up all the ATSC 1 programming onto the others. This, of course, leads to our next problem. The transmitter that served the combined ATSC 1 programming will get very crowded. So a much more effective compression mechanism becomes very essential in this picture. And this is where Ateme can help. But how? Let's take a look at an example. So over here in this example, we have 3 stations, each having some typical HD and SD channel lineup in the ATSC 1 world, and each with their dedicated ATSC 1 transmitters. Actually, some of you might already think that the station 3 is running a pretty heavy load with 1 HD and 5 SD channels in the ATSC 1 bandwidth. Well, with Ateme's advanced high efficiency compression algorithm, what we can do is during the period when station 1 is refining its ATSC 1 transmitter into ATSC 3, we'll simply move its 1 HD channel to station 2. Let me put on the laser pointer. We'll move its 1 HD channel in ATSC 1 format into station 2. And the 3 SD channels in its ATSC 1 format into station 3. Meanwhile, station 2 and 3 will be spinning up the ATSC 3 version of their 1 HD and 4 SD here and 1 HD and 5 SD here onto ATSC 1's future ATSC 3 transmitters. And this is also with the HEVC codecs. So you'll be able to achieve the same video quality as we mentioned, or if not higher. Meanwhile, only about 25% of the bit rates from the traditional ATSC 1 MPEG-2 codec. As for the ATSC 1 channels, station 2's transmitter will be running 2 HD and 4 SDs in total, and station 3's transmitter will be running 1 HD and 8 SDs in total within the 19.39 megabits per second limited bandwidth. Now, these channel counts are not just made up numbers. These are real density numbers from projects that we have managed to launch with real customers after they were impressed with how much we could offer for them. All right, so now that you've seen the incredible density we can provide with your ATSC 3 solution, what else would you want to go with Ateme for your needs? I believe it's the fact that while our solutions are feature-packed, our engagement models are extremely simple and transparent, as I can say it. We've had customers just coming to us after receiving our quotes. Hey, did you miss something? I am only seeing 1-page PDF here. Typically, I would receive like 3-page from another competitor or 5-page from the other vendor. Nope, that's it. That's everything. Our engagement models are input-based. If you have this many inputs, that's going to be everything on the quote, with every cutting-edge features included, of course. If you decide to add, like, say, 100 more outputs with the exact same input tomorrow, you already have all the necessary licenses to do so with that affordable price you have paid yesterday. If you decided to run our solutions on-prem with a VM or standalone today, but move it to the cloud with Kubernetes tomorrow, it gives us a, just give us a ring and we'll help you do so. No question asked, no strings attached, no nickeling and diming here and there, because you already own the solution. And we always cater to all kinds of deployment variations. Every time we release a new GA, you're gonna see the ISO file, the tar.gz file for cloud deployments, the Bing file for upgrade, everything. And there's also no limitations or restrictions. The more powerful your platform is, which is your chosen platform, you can go with us, or you can choose to provide your own platform. The more powerful your platform is, the more you can achieve with our solutions. So let's come back to the slide. As you can see, you will be using the exact same intuitive and high quality Titan solution for all workflows you desire. And I'm gonna prove it in our demo later on. Let our workflow to be ATSC 1, ATSC 3, or OTT, CDN, you name it. And there's hardly any learning curves because it's the same software. Over at the top is our optional Ateme management system, very popular among many customers for real-time monitoring, failovers, and controlling scheduled tasks via API calls, as all of our softwares are open API. One nice feature that I particularly like about our AMS is, say, if you have 200 substations you need to manage and you put your AMS in a central location, you can directly click into each of the monitor elements to gain immediate access. So you don't need to worry about asking for TeamViewer credentials that changes dynamically or managing different VPNs. Everything is just within the reach of a click. And then of course, at the bottom, that illustrates more. We're not really locking you down into an appliance or a proprietary software that limits you into just outdated protocols that you cannot really work with other vendors or other solutions. Everything is open with us. We're providing you a future-proof solution with extraordinary user experiences, I would say. And here comes one of our happy customer, Pearl TV. As some of you already probably know, Pearl TV is a consortium of the top US broadcast companies exploring forward-looking opportunities. Nowadays, they're recognized as one of the pioneers in the ATSC 3 development. At the very beginning, Ateme was just one of the several encoding vendors invited to Pearl TV. However, after about several rounds of Plugfest events, they're now inviting Ateme as the only encoding vendor to these events. Why? For the exact same reason we've mentioned earlier. Everything's included in our feature-packed software so that the customer do not need to worry about constantly modifying their arrangements and dealing with workflow changes or learning curves. With such close relationship with Pearl TV, it also guarantees Ateme to be at the latest forefront of ATSC 3 ecosystems. And it doesn't stop just at Pearl TV. Down at the bottom, as you can see, these are many other deployments and trials we have taken pride in. Sinclair, before they joined Pearl TV, they were working with us individually. As of right now, they're working with us on two fronts, as they just joined Pearl TV. We have Dish, we have WRL, which is very active in ATSC 3 development. NAB, the association itself, we have their signal up in the air in Cleveland. MPG Group, which is also very active in ATSC 3. We have University of North Carolina and the New Mexico PBS. I would say almost all of them, if not all, many of them are no longer trials. They're live ATSC 3 signals that have been on the air for quite some time. And here is another happy Ateme customer. As many of you already know, Ateme is the exclusively chosen vendor by Sinclair. the second largest station group in the nation, who's also well known for its aggressively active role in promoting ATSC 3 at all fronts. But it's not just Sinclair. There are actually at least 5 other top ATSC station groups that have chosen Ateme, but we just cannot disclose their names yet because we have not asked for their permissions to do so. We're very careful about that. Why haven't we asked? Probably because we are so busy fulfilling the orders. Just between myself and a couple of coworkers, before everybody's locked down at the home, we actually have helped launch over 80 full power stations and over 30 low power stations, all within the last few months. And they were all for refining and improving the current ATSC 1 programmings, at the same time laying the foundation for ATSC 3. For many of the customers, that was the very first time they were working with Ateme. But as soon as they saw our video quality, our surprisingly pleasant user experiences, I'm mentioning it again. Yes, I have to show you now. Our eye-opening, cost-effective solutions, and most importantly, I would say the tremendous amount of opportunity we're presenting, they had no hesitation to go with us. So here we are. And then at this point, if you don't believe about anything I just said, please do stick around for the demo. And if you do believe me, please still take me up on the demo. And here we go. Let me find it. Okay. All right, so here is an ATSC 1 StatMux with 2 HD channels and 5 SD channels. These are real density that's been running in some of the stations. Not the most aggressive one, but not an easy one for other encoding vendors. And you can see under system information, it is currently only using 30% of the CPU on this very low-end lab system we have. And also, please take a note that I'm using HEVC IP input sources for this particular demo. Typically, you will probably have like SDI sources, which do not require decoding. So that means there's going to be much less resources being occupied. And even on this 1RU low-end CPU platform, it's using only 30% of CPU. And that means we could easily squeeze in both the encoder and the mux together onto same 1RU chassis, either using VM or Dockerize it. And so far in the ATSC 1 world, the most aggressive profile I have done, I believe it was like 1 HD and 12 SD in a single StatMux pool using VM to squeeze the encoder and the mux together and running on this exact same medium to low end CPU. And that was for about dozen stations with a low power station group. And if you have like multiple stations to serve, you can also run everything with one chassis, 1RU chassis or 2RU chassis, depends on what kind of PCIe boards you go with. If you have like multiple stations to serve, the most aggressive density I have personally deployed is totally 10 HD and 15 SDs across 5 different ATSC 1 StatMux pools. Also with VM and to put encoder and mux together on the single unit with a slightly more powerful CPU. And that was for a full power major station group. Now that we're here, let's just take a look at the GUI, since I have to keep up to my word that it's intuitive and smooth experience. System information, you've already seen here. We have system CPU usages, temperatures. VCA nodes doesn't really apply here. It was some for old IP in, IP out, MPEG-4 workflows. System management, We have all the basic configuration here, license management, and you can customize and configure your logos and fonts here. We have many customers use our logo insertion features to fulfill their legal ID requirement. Like I said, everything is open API. So all you need to do is just to integrate API calls via a Python script. You can get all these API instructions under the support tab. You can simply just, I hope my VPN did, okay. I'm sorry, because I'm going through a VPN tunnel, you're gonna see these offline disconnect from time to time. I hope that's not gonna be a usual thing. So as I said, all you need to do is integrate the API calls via a Python script and schedule the IDs or the logos to fade in at the top of the hour and then fade out after like 15 seconds. Or if you prefer a much cleaner way, you could set up via a nice interface on our AMS system. And the fade in and the fade out, of course, is not gonna cause any glitches or system restarts. Otherwise, it's not meaningful for you. And over here, we have our NTP information. System update tab. You can upgrade and downgrade to different firmwares easily. And then once you initiate that process, it's gonna ask you to confirm so you won't be fat fingering anything. And at the beginning, it will do all the GUI and the database restructuring, updating with everything still up and running. And until the very last minute, it will do a quick restart just to make sure there's minimum interruptions. Over here, we have the network management. You can associate logical names to the individual interfaces. That's one thing I always do just to keep track of everything. And then you can also utilize the NIC bonding feature for extra layer protections. Down at the bottom, we have here the default gateway and then the particular routes you want to establish. And then down at the bottom, we have the StemMux pool configurations. This is where we define the various StemMux pools in order to establish a proper StemMux communication with the MUX software later on, which we will visit. That's everything about network management. Let's move on to alarm management. Over here, you can customize all the SNMP. You can enable the traps and then manipulate the alarm levels here on the right. Again, if you couple it or companion it with AMS, Ateme management system, you can set up automatic failover, different rules based on different alarm levels and other conditions. You can really get creative there. For example, if I'm doing input redundancy and both my input links are down, then I can trigger AMS to fail over to my backup unit in the hope that it has its input up and running. And then if I have all my outputs down, of course, that's a condition where I want to trigger AMS for a failover. Logging configurations, you can forward the logs to a central management server. Password management, you can create and customize different user groups and privileges. So only designated users will be able to make changes. Your operator will only be able to view them. Hardware monitoring, pretty standard. We got the CPUs, the fans. And of course, if you're running this on a VM, you're not gonna see direct information because these will be monitored via the VM. But here on the lab system, I'm doing a standalone system, so you'll be able to see all this information in the Titan software. Let's take a look. We just briefly mentioned the support tab. Here is all the API documentations, very straightforward with examples, and then you can integrate into a Python. Everything's open API. You can open a terminal here, or you can, I prefer not to open the terminal within the software because who knows who's going to access at the same time, make mistakes. And then over here is where you generate the diagnostic package. So sometimes if you reach out to support and we ask for a diagnostic package, you will click on here and it will ask you to wait while it's generating the package. Give it a couple seconds. Okay, it's ready for download. Then you can click on this download, and it will be downloading to whatever computer you currently use to access the software, not on the encoder itself, flooding the hard drive. And also at the same time, you don't need to worry about finding a USB drive, scan to make sure it's virus-free, plug into the encoder, get the file onto it, take it out, and scan it again to make sure it's virus-free, since virus is a very sensitive topic nowadays. This way, everything is just direct access from encoder to your local computer. Over here, we have the alarms tab. Here are all the alarms, and you can view them all, or you can, sort them with the different level of alarms that you care. Or sometimes if you focus on one particular channel, let's say in this case, I want to look at anything associated with HD number 2, and I'm only being presented with anything associated with HD number 2. You can also sort them by type, whether it's because we changed the configuration of the service, or encoding has stopped, started, and their current status. And then if you feel that this is past information, I want to keep it clear, you can just clear the non-open alarms. So this means there's no active alarms for you to worry about. And of course, all the past alarm messages will still be available in the logs, should you want to find out later. Okay, now let's take a look at the encoding services. Here, we are greeted with the thumbnail views of all the services. And you can switch to the list views to have all the parameters show up in one page right here with all the detailed parameters. And if you just single click on one, here is the thumbnail again, the same button layout, start and stop services, edit service, delete it, export it, and force a blackout. And of course, you can do it in the thumbnail view too, the same button layout. All these profiles are JSON, and importing are within a couple seconds. So you can export one service. Let's just call it HD01. Or multiple services. Or you can do all services. Let's just call it TL, Titan Live. Today is 15th, yep. Okay, everything's downloading to my local computer. And then if I accidentally delete it, of course, it's gonna ask you to confirm it. So that kind of stop you from making easy mistakes, but still, mistakes are to be made. Oh, what do I do? You just simply find your previously exported services. Here we have the TL0415 that contains all the services. You just import it. Oh, did I click on the, yeah, I need to click on the start button, and we're back in business, waiting seconds. Okay, let's take a look into how to configure a particular service. Again, I want to apologize for the latency. I'm really going through a VPN tunnel. Real world experience is much more faster. Remember I said our solutions are intuitive and clean lines? Here is how intuitive it is. You open a page, you fill in the parameter, you click on a check mark, it natively flows you to the next phase. And it's like input, and we define our output configurations. Okay, we have all the parameters filled out. You define what type of output format you want to have. And once you fill that in, it asks you how you want to receive it, whether it's in form of a file or like a live stream. So everything is just natively moving on to the next subpanel, moving between all these pages. You just click on one item, it opens up like a browser. And once you click on this checkbox, it just moves on to the next phase. No more right-clicking forever to find that hidden menu or trying to figure out what it means to be like a physical input or virtual input. You know what product I'm talking about by this time. and no more trying to maintain an outdated version of Java just so to run the program, or downloading resource hogging plugins to open like an overwhelming science project. Everything is just straightforward and intuitive. And the best part is it looks simple, but it's feature packed. All these features are packed within the same software, regarding if you're doing ATSC 1 or ATSC 3. Look, it's the same software. Oh, it logged me out because I've left logging for too long. In this example, I am doing the IP input, as I mentioned earlier, but here's the SDI input. Here's the SDI 4K input. You can also do RTMP, receiver demodulator, or AVSB. So you can receive all these satellite signals, Zixies, 2022-6, and 2110 is coming soon. So we're done with our input. You're putting a multicast address and then define your network interface to receive it. Well, for the IP process, of course, you need to probe it, and it will give you all these details, what codec it currently is. Look, it's the HEVC input, so it's pretty heavy input to begin with. So if we're doing SDI, there's going to be less CPU usages. It's already doing Adobe AC3 for me for the audio, so I don't need to waste my Adobe licenses. I can just do Adobe pass-through. And for the video track, I am doing ATSC 1. So we're using MPEG-2 right now, but the other codecs, MPEG-4, HEVC, JPEG 2000 also here. Later on, if we have other codecs, they will be all added here. Same software, no learning curve. And click on Show More. We'll be able to customize various parameters like your aspect ratio, AFD, whether you want to do HDR or SDR, and a whole bunch of other VQ optimizations. Same with the audio. We have the Dolby pass-through, and then you can also do Dolby encode. That is AC3, of course. We got MPEG layer 2, MPEG AAC, AC4. And moving on to the data tracks, we have 608, 708, whole bunch of various SCSIs, Nielsen watermarking, ID3, and much more. So that's it. We define our input, we define our output. Now we just select what output format we want to do. And like I said, one input, unlimited output. Here they are. Once you install the software, everything's already in here. We don't really limit you. We have TS, transport stream, multi-TS, HLS, dash, smooth streaming, RTMP. In this case, because I'm doing ATSC 1, we chose the TS, and then we assigned the video, audio, and data tracks. And then here, I'm checking the box for enable StatBox, and you fill in the rest of the parameters. Many of them will be overwritten by your PSIP carousel, but I like to fill in as much accurate information as possible just to keep track. And once you define your output format, you want to just tell the system how you want it to be received. Here I said, yeah, just receive as a multicast stream. So I just put a arbitrary multicast stream, or actually it depends. If you're running everything within one system, because it's all going through the virtual switch of the VM or Kubernetes or Dockers, you can use any arbitrary multicast addresses. But if it's two different machines going through a network switch instead of a direct connect, you would have to use some reasonable multicast addresses. Yeah, let's note down this one, 239.18.1.101, port 1234. So that's how we're multicasting the compressed output for HD01. And then we move on to the next piece, which is the MUX. And then on the input side of the MUX, we put in the exact same multicast address so that you could receive the encoded outputs. And then you're doing all these on a single unit using VM, or like I said, if you're doing everything in a single unit, these could be arbitrary IP addresses, and there's not going to be any traffic flooding on your network because everything is internal. Then we come over to the MUX output. We define an ATSC1 MPTS and drag and drop the selected inputs. At this point, you have an MPTS, but no StemMux yet. Here's the StemMux. Remember on the back on the Titan Live encoder network management tab, I was showing where StemMux are defined. Here is where we put the exact same multicast address just to finish the last piece of the puzzle. Then you simply drag and drop programs from your MPTS into the StemMux pool. Right now, I just have everything free run. As you can see, everything is free run. So it's very, I will say, noisy or busy. But if you have obligations like every Sunday afternoon between 2 p.m. and 8 p.m., you need your first HD channel to run at a minimum bit rate of AMAG and then tune it down afterwards. You could, again, schedule some API calls either through Python scripts or via the nice UI of Ateme management system. One important thing to note is that when you make these adjustments, it's seamless to the end user. No glitches, no disruptions. And of course, most importantly, there's no missed spots. That's what's most important for a football game. Like right now, if I just make my HD1 minimum AMAG, hopefully I got all the zeros right, and move over, you can see it dynamically adjusts to, there's no gap. That means the signal never stopped and there's no glitches. So it's already running a minimum of AMAG, the extras or the audios and other data. And just as we briefly mentioned, here's another system running on the same mid to low end CPU, but it's running a version for ATSC 3. As you can see, same software, same GUI, pleasant user experiences. This doesn't mean your ATSC1 software, doesn't mean you need the two different versions to run ATSC1 and ATSC 3. This is simply because this is a newer version of ATSC 3, and I want to show you how they're identical and then they can run on the same hardware. That's why I'm just splitting the two systems. It's just a single software, same layout, everything. Same pleasant user experience. So, as you can see, this is how Titan looks and operates, and hopefully you have the same feeling as me of how clean line, how smooth, and how pleasant to use it is. I believe it's time to see if we could answer some of your questions. Amilcar, are you still there? Did all my audience fall asleep already?
No, they're all here. We've got
okay.
people here.
Great.
So yes, we do have a few questions here. So one person in the chat room, he's asked, I guess he's familiar with our CM5000 products. What happened to our Kirion and CM5000 products since they weren't on your presentation?
Oh, okay. Yes. Well, originally I was going to put it in, but I feel like because the focus of this presentation is on the Titans, so I did not mention them. But we still take very much pride in our traditional FPGA-based Kirion products, and they are still in huge demand. Actually, I just received a whole bunch of emails about them today. As a matter of fact, if you ever walk into any of the 230 CW affiliates or any station that has a Cisco D9096, which is a rebranded Kirion product, you have already been working with an Ateme Kirion system. So that's really how popular they are. They're really great for low latency contribution projects.
Hey, excellent. We have another question here. This is from an anonymous person. I think that somebody got confused with SHVC. Could you address that real quick?
So I think we already mentioned it. It's actually in one of the previous slides. So let me, let's just go to it. Oh, I went too far. So his confusion is around SHVC. He just want a more detailed explanation.
What is SHVC?
Okay, basically. Right. So we have the HVC that everybody already knew, right? So SHVC is the scalable extension in HEVC. So like the name itself is very self-explanatory. It's about making everything scalable. As of today, we already enjoy the temporal scalability via the first generation of HEVC, and it will be able to enjoy more scalability via SHVC, whether it's in the spatial world, whether it's in the signal to noise ratio, or in the bit depths, or the color gamut. And then, of course, there's a lot of benefits associated with making everything scalable. You're going to be able to consume less network bandwidth, there's going to be less network congestions, and there's going to be less storage size to occupy. And then most importantly, you're going to be able to receive more programs or higher quality programs, because I think essentially it saves overlapping efforts. So basically you have more rooms for the benefits.
We have another
Feel free to correct me.
here. No, it's all good. SHVC is, you know, Bill's also on this call, a base layer, enhancement layer. But we have another question here.
Right.
Is it possible to add a manual recording for a currently running output on Titan Live?
A manual recording of the current output. Yeah, you can, because the output is unlimited. So what you can do is, if you're asking for Titan Live, yeah, because everything out of Titan Live is IP, right? So let me pull up my GUI here. Everything on the Titan Live, the output of Titan Live is on IP. So if you just point it to a transport like TS reader and it should record, you can record it. And then with Titan Mux, you can have ASI or IP output. So with the ASI output, you could use some tools to encode it, but at the same time, you can create a IP output and then point it to any IP recording tools, and there you go. And then often, like say, if I'm deploying a project, we encounter some issues to be concerned on ASI output, I would spin up the IP output to make sure we find the consistency over there first. And it really helps us a lot. Did I answer that question?
Yes, I think so. Another question we have on the Q&A section. Let's see. Are we going to support SRT as an input to Titan Live?
Yes, it is already on the roadmap. It is, as of today, we support ZXC already, and SRT is on the roadmap. On our Kirin products, SRT has already been supported. As of today, you can use the third-party tools to emulate the SRT into Titan Live and Mux. We've demoed it before, but I believe it will be much nicer to have it natively integrated into the software. So it's just like a checkbox as ZXC.
Okay.
Yeah, right here we have the checkbox, and over at the input, it's just a drop-down menu for ZXC. So SRT is probably just going to show up at the same area. No learning curve, same software.
We have another question here regarding input streams. Is there a ceiling? How does the basic question is how many input streams does this machine support? But yeah, what are there limitations in terms of inputs into Titan Live?
It really depends on which platform you choose. Again, like I said, we don't sell you appliances, and then you can choose to purchase server through us, or you can choose whatever server platform you want. The more powerful your CPU is, the more streams you can receive. And then, I mean, input stream, it's a combined data between like inputs and outputs. On this mid to low end CPU, the Intel Go 6140, my personal experience, if you want to do MPEG, I think I've previously tested, you can do 10 IP in and 10 IP out MPEG 4 encoding with this particular CPU, and you can achieve much more, like 25 of them on a slightly more powerful CPU. But we don't lock you down in any platforms.
It's a software solution, and there's no physical spigots, so it's really about how much bandwidth you have and how many services you can actually handle, right?
Exactly. You can even put in like the 25 gig network cards just to make sure you have enough bandwidth.
We have another question here. We still have time. Getting close to the 4 o'clock mark, but we still got some time. somebody's asking, what type of controls do you have with the StatMux to control bit rates?
Oh, it's right here. Yeah, let me spend more time on it. So we have minimum bit rates. We have the maximum bit rates. And we can also customize the priorities, which is called relative quality. That means how relative the quality is compared to the other services. And the target quality, which means during a bitrate wall, whether you want it to get 100% of the potential bit rates or only 50% of the potential bit rate. So if I'm spinning up a service in an ATSC 1 station here, with this profile, I'll probably do 6 meg minimum for the HDs, or you can tune it down a little bit because everything will look amazing with 5, even with MPEG 2 with our software. And these are real data. And then for the SDs, typically they should be at the lower priority than the HDs. So I would assign them at 25. You can also cap you can put a minimum and maximum bit rate for the SDs, but I'm just gonna make some basic changes here to show you how much effect it has made on the histogram. 25, 50. I wish I can type faster. 25, 50. And remember, that was a very busy histogram. Now it's going to be slightly more flat because we're putting a ceiling and roof, and then we're restricting some of the priorities. As you can see, the HDs will never drop below 6 meg, and SDs are fighting among whatever's left. So we have 19.39. You have to subtract the audio, the other data, and then the PSIP data, if applicable. And then they only have what's left to fight between. And if you one of the channel of the SD is, maybe it's too low, and you can set a minimum bitrate for it so that it doesn't like really drop below 1 meg or something. But, and of course, your histogram is gonna look flatter. And it's different preference. It really also it's also a factor how busy your source is. Like for example, HDO1 is really on the talk show that hardly moves, where HDO2 is slightly busier. So as we can see, it's occupying more bitrate than HDO1, even though they are set at the same priority, same minimum bitrate.
Okay. We're running very close to out of time, but one final question. What about ad insertion? How does Titan support ad insertion in ATSC workflows? So
as of today, in the ATSC, I wouldn't say it's ATSC 1 world. As of right now, in this version of Titan, which is not the latest, we support ad splicing, communicating with external ad servers, utilizing SCSI 30 and SCSI 35 triggers. And then if you talk about the dynamic ad insertion in ATSC 3, we use the X-links, which I actually have some other documentation that we can look deeper into offline.
Yep, I think that's a pretty deep subject that we can certainly expand upon. And we also have an ESAM interface that allows us to integrate with different voice systems when that's necessary, though perhaps not so germane to ATSC 3.
That's correct.
But,
so that's why I didn't mention it.
Yeah, but it's another little thing, another aspect of ad insertion that we support. But yeah, I think this is gonna be it for us. We've answered almost all the questions. If you guys want to talk about ad insertion later on, feel free to send us an email and we can schedule a more in-depth session around ad insertion. Thank you so much for joining this portion of Attempts 24. There will be a recording if you'd like for us to send it to you, or a link. Just again, send us a note. I think actually you may get an email automatically to see this video. So, but that's it. Next up, I think it's going to be reach new audience with virtual programming. For those of you already in this room, you're welcome to stay for that presentation. But that is the end of this session.
Yes, thank you. Thank you all very much. Yep.
All right. I think next up is, let's take a look. To whom shall we pass the baton? Bruno is going to be moderating that session, and the presenter will be Germán Capellán.
All right. Let's find Herman. Herman, are you there? I just made you the panelist.
Okay, hello to everybody. Now I have the control. Let's put also Bruno, who is the moderator. Just give me 1 second.